All right, welcome. Let's continue our journey of learning trigonometry. By now we should feel good with trying to find sine of 45, cosine 45, sine of 60, cosine 60. Now let's try and see what happens if we try and do sine of 150 and cosine of 150. So this is saying that imagine if you have an angle that's 150 degrees. If this is quadrant 1, right? This is quadrant 2. This is quadrant 3. This is quadrant 4, right? And remember, if the sun is over here, our degree is 0 degrees. Here is 90 degrees. This is 180 degrees. And this is 270 degrees. Where do you think 150 degree rotation, like if I move this sun 150 degrees, where will it land? Pause the video and think about it for a second, but it should land over here in this quadrant, because if here to here is 90, then you need 150 is between the 90 and 180. So we know that the angle should look something like this, right? And this is our 150 degree angle. Okay, and let's just always be very conscious about this. Remember, this is our initial ray, always have it in the orange, and this is our terminal ray, which will have it in the green. And the question is, how do we find sine of 150 and of 150 degrees, and how do we find cosine of 150 degrees? Okay, here I have the notes for you, and you should all have this. But if you don't, you can just let me know. Oh wait, let me zoom out for a second. Here are the steps for calculating sine of theta and cosine of theta of angles greater than 90 degrees. So we're just going to follow these steps. And if you don't have these steps, raise your hand and let me know. Or if you want, you could just copy them down right here. So this is step 1, this is step 2, this is step 3, and this is the definition of reference angle, which will be very important. And the last one is step 4 over here. Okie dokie. So let's look at the steps. Step 1, put a point, right? Put a point on the intersection of the terminal ray and the unit circle. So if this is my terminal ray, which is the green, and my unit circle is this circle over here, where is the point where this ray and the circle intersect? It's this point right here. Okay, that's the point. Boom, we did step 1. Step 2, it says drop a perpendicular line from that point down or up to the x-axis. So basically, you will draw a line that will hit this x-axis. Remember, the x-axis is over here. So here, we're not going to go up, we're going to go down. Okay? Okay? And now we get to use this. And notice, what did we create? We created a triangle, but a very special triangle, because we know that this angle is 90 degrees, and the question is, what is this angle over here, right? Well, let's think about it. It says here, for number 3, it says use algebra to calculate the reference angle. This angle over here, remember, the elevation is called theta, and the reference angle is called phi. So how do we know what this phi is? The reference angle is the smallest angle between the terminal ray. If this is the terminal ray, it's the smallest angle between the terminal ray and the x-axis, okay? And here, the smallest angle between this terminal ray and the x-axis is this angle here. But then the question is, here, let me zoom in a little bit, is how do we know what this measurement is? Well, here, remember the properties of a straight line, that if this is 150 degrees, right? If this, let's try and match this. If this is 150 degrees, then this has to be 30 degrees, okay? And if this is 30 degrees over here, right? Which triangle can we use? We could use our special triangles. Remember, these triangles are very important. This is the one, this is the 30, 60, 90, right? 30, 60, 90. Use the posters on the board, but this should be what? A half. This should be square root of 3 over 2, and this should be 1. And notice that why does this help us find sine of 150? Remember, sine represents height, right? Remember, if I say what's the height of this point, it's set up and down. You remember the paper plate model, how we went up and down to find the sine? And how do you find the cosine? It's the coheight, right? So here, what is sine of 30 degrees? It will be a half, okay? It'll be a half. What's the cosine? You see, this is sine. It's opposite. It's 1/2 divided by 1, opposite over hypotenuse, and that's just equal to a half. What's cosine of 150? Let's do it over here. It's adjacent over hypotenuse. So it's square root of 3 over 2 divided by 1, which is equal to square root of 3 over 2. But we have to be a little bit careful over here, because this is correct, right? But this is not 100% correct. What we have to do real quick is, do we have this picture over here? Hopefully you have it from the last video. That, remember, here, think height and think coheight. Here, if your sine of theta, remember sine of theta, here we'll put sine of theta over here. We'll put sine of theta over here. Put sine of theta over here. Let's put cosine theta, right? Okay, and this will all make quick sense in a second. So cosine theta, cosine theta, cosine theta. Now the question is, positive or negative, right? Now let's think about it. Remember, if this is the y-axis and this is the x-axis, remember, if you're the y-axis, everything up over here, this is all positive, right? Everything below the x-axis is negative when we talk about the y function. But everything to the right is positive for the x, and everything to the left of the x is negative here. So here, our sine of theta, if we're thinking about height, our sine of theta is positive. What about cosine theta? Remember, everything to the right, this is positive. Sine of theta, we're above the y-axis, this is positive. But cosine theta, you have to think of the x, everything to the left is negative. Here, everything below the x-axis is negative for height. And here you're still on the left side, so this is negative. Here, we're below the x-axis, this is negative. And here, we're to the right, so this is positive. So, if your sine of theta or cosine theta in quadrant 1, if your sine of theta or cosine theta in quadrant 1, you're positive and positive. If you're in quadrant 2, your sine is positive, but your cosine is negative. So that's what's happening in this question here, in this part. Here, we're in quadrant 2, so I know my sine is positive and I know my cosine is negative. So this sine is positive a half, but here, this should be negative square root of 3 over 2, not positive, okay? And that's it, and we did it. Okie dokie. You got to use these triangles. What I want you to do is, let's try and do the next two questions over here. All right, let's try and do the next two questions over here. Suppose we have 120 degrees. What do you do? Let's say you have 240 degrees. What do you do? And let's say if you have 330 degrees, what do you do? What I want you to do is pause the video and try your best to solve these. And what I'll do is I'm going to pause the video myself, and then I'm going to solve them, and then I'm going to show them for you. 120-degree rotation, if you make a 120-degree rotation, it should be in quadrant 2. And notice that if this is 120 degrees, right, what will be the reference angle? The reference angle will be where? Well, remember, let's just follow the steps nice and clear. Step 1, what does it say? Put a point on the intersection of the terminal ray and the unit circle, right? So let's do that. Oh yeah, I forgot to put the Got to draw the circle over here, right? Okay. Here, we draw this point over here that hits it. And then what do? We draw a line that goes down. And notice that this is the triangle that we make. Now the question is, what's the reference angle? What's this angle over here? The angle between the terminal ray and the x-axis. If this is 120 degrees, then this has to be 60 degrees because it has to equal 180 degrees with the straight line. So if this is 60 degrees, then which triangle are we going to use? We're going to use the 60, 30, 90 triangle. 60, 30, 90 triangle. And if you look at the board, this should be square root of 3 over 2. This should be a half, and this should be 1. So if I say cosine of 120 degrees, if I say sine of 120 degrees, it should be equal to opposite over hypotenuse. So our opposite is just square root of 3 over 2 divided by 1, and that's just equal to square root of 3 over 2. Now question, positive or negative? And remember, it's in this quadrant 2, so our sine is positive, so this is okay. Well, let's look at cosine of 120 degrees. This should be, if this is the 60, right, it should be adjacent over hypotenuse. So it should be a half divided by 1, and that's equal to a half. But the thing is, our cosine theta should be negative because it's in this quadrant. Remember, you're on the left of the x-axis. So this will be negative, okay? And that's it. That's all you need to do. Let's do the next one. Here, it says 240. Well, here, if this is 0, this is 90, this is 180, this is 270. And let me just draw the circle real quick, okay? Here, where will 270 degree rotation be? It should be, this is 90, 180. So 240 is somewhere over here in this quadrant, so it should look something like this, right? This angle will be a 240 degree rotation, right? Now here, we have to calculate reference angle. What is the reference angle? Oh, sorry, whoops. Before we do that, what do? We draw this point over here, bring the line down, and we create our triangle, right? And we know that this distance is always 1, right? Because it's the unit circle with radius 1. So the question is, what is this reference angle over here? So here, remember, don't forget that reference angle is the smallest angle between, wait, let me zoom out a little bit, my bad. Reference angle is the smallest angle between the terminal ray and the x-axis. What is the angle between the terminal ray and the x-axis? It's this angle over here. Oh, sorry. Right. What is a reference angle? It's the angle between terminal ray and x-axis, which is this angle here. So if you know that this is a 240 degree rotation from here to here, what is this angle here? It has to be 240 minus the 180. This angle here, this has to be 60. So if this is 60 degrees, we're using which triangle? We're using the 60, 30, 90. Right? We're using this triangle. This is 1, this is a half, this is square root of 3 over 2, right? And you just do the same thing. Sine of 240 degrees will be the same as this sine of 60 degrees. So sine of 60 degrees is opposite over hypotenuse. So it's just square root of 3 over 2 divided by 1, which is equal to square root of 3 over 2. But wait a minute. Oh, sorry. But wait a minute. Positive or negative? And we have to look here. It's in quadrant 3, right? If it's in this quadrant on the bottom, so then it's negative. Okay? It's negative. What about our cosine theta? What will it be? Positive or negative? It's going to be negative. And our cosine theta will be this adjacent over the hypotenuse. So cosine of 240, right, will just be negative a half divided by 1, which is equal to negative a half. Or actually, if you don't want to write the one negative a half, that's okay. Just write it after. But it should be because it's in quadrant 3. Okay. Let's go to the next question over here, last one, and then we're done. Let's look at this one. If we have 330-degree rotation, what do we do? Remember, if this is 0, 90, 180, 270, our rotation of 330 degrees should be in this quadrant 4. So I'm just going to draw the terminal ray somewhere over here, right? And now here we just draw our circle, okay? And then what do? We take the point, drop it down, and now here we want to find reference angle. Reference angle. And remember that this rotation is 330 degrees, right? This whole entire rotation is 330. So what is reference angle? Remember, reference angle is the angle between the terminal ray and the x-axis. If this is 330 degrees, then what is the measurement of this angle? It has to be 30 degrees. And if you're thinking, why? Well, here to here is 330. How much more is left? If this whole thing is 330, right? How much more is left to get to the x-axis? And remember, this is 0 or 360-degree rotation. It's 30 more. So then we're using this triangle of 30, 60, 90. And we know that this should be a half. This should be square root of 3 over 2. And this should be 1. And our sine and cosine, remember, our sine and cosine, sine will be negative and cosine will be positive because it's in quadrant 4. So here, what's our sine? It's just, if this is the 30-degree angle, it's opposite over hypotenuse, so it's just 1/2, but it's negative, so it's negative a half. What's cosine? Oh, sorry. Let me put 3. Yeah, let me do that again. Sine of 330 degrees is negative a half. What's cosine of 330 degrees? It should be this adjacent, which is square root of 3 over 2. And it's positive, right? Because it's in quadrant 4. Okay? Now here, if you see this circle, notice that it tells you all of the answers, right? We just did we did 330, right? This is the, remember here, this is the cosine, and this is the sine. Notice that we got the same thing. It's right here. Here it has all the solutions for every single angle. But what I'd like you to do is to really understand what to do. I want you to do all of these. A lot of students did these questions, but if you really want to understand what's going on, do sine of 120, cosine 120, sine of 135, cosine 135, sine of 210, cosine 210, sine of 225, cosine 225, and just do all of these, okay? If you really want to understand what's going on in trig, you really have to understand how to work around with this circle. It's a lot of work, but welcome to being an adult and working hard to obtain great results. Okie dokie. I will help you. I will see you.